Hello, so today we are going to do problems from weekly contest 422. The second problem is find minimum time to reach last room. So basically we have, you can think about it as a dungeon with n by m rooms that are arranged as some sort of a grid, so something like this. And each cell is a room, and we have this move time array where basically the value in that move time at position I and j is the minimum time in seconds where you can start moving to a room. Now, this basically means the minimum time that you can just add 1 to go to the next room. Now, why 1? Because you can move to an adjacent room with exactly 1 second time. Okay? And adjacent here is either horizontally or vertically. Okay. Now the problem asks us to move from position 0, 0, 0 to a last position n minus 1, m minus 1. Okay, and we can take any route we need to. And the goal of the problem is to return the minimum time it will take us to reach from 0, 0 to reach this n1 minus 1 position, last position, right? So if you take a look at the first example here, to get from room 0, so to start moving to room 0, 1, you need to be at time 4, right? So at that time 4, then you can move from 0, 0 to, to be able to move to 0, 1, or to move to 1, 0, you need 4. So at t equal to 4, we can move to 1, 0. And then at t equal to 5, because 5 is bigger than 0, we can move to 1, 0, which is this one. We can move from this one to this one, right? And so we can, because 5 is bigger than 4. Okay, so we move to that one, and that's the last one. So the sum is going to be 4 here, and then 5, and then within 1 second we'll get here. So 6 total. So that's the idea. Now the array is not too big, right? 50. So any n squared solution should be fine. But how do we tackle something like this? Okay, so how do we tackle this? Well, the first thing to think about is what is the problem here. It's finding the minimum time to reach from 0 to the last position. This is usually finding the shortest path, right? Except here we have an additional constraint, which is that we can't move to the next room until we reach its move time, right? So that's the only thing that we need to take into account. And here we need the minimum time as well. It's not just the shortest path and every point going from every point to every point is just 1, right? There is a min time value. So what we can do here is basically just use Dijkstra. This is what it is for. And for Dijkstra, what we need to represent is we need to have a priority queue. And in our priority queue, we need to store some values. Well, we definitely need to store the position, right? But we also need the time, right? Because at the end, what we want to return is the minimum time. So the time it takes to reach a point. And that should be it for this problem. Yeah, that's all we need here. Okay. Now, when we reach the last position, then we can just return the time we reached that position at. And for each point, we want to visit the neighbors. Now, the neighbors, the problem says only the ones that are adjacent horizontally or vertically, right? So that would be I plus 1 going right or going left, and then going up or going down. So that's these two. So those are the direction. And then for every direction, what we need to do is just basically, if it's not visited yet, and we can just maintain visit time in maybe something we call min time or visit time. So we can have like a map here for it, and if this is not in it, then that's mean we did not visit it, right? That's pretty much it. So pretty straightforward, and then when we reach it, we return the value. So let's just code it up quickly here since it's pretty straightforward. So what we need is we need a priority queue for our, because here why we put, also another thing to mention is why we put time first here. Well, this is because we want to priority queue, we want to pop the smallest time first, because that's our goal, is to get the minimum time. Okay. Now the other thing we need to make sure we take care of is we can only start moving to the room when move time is reached, right? So how do we handle this piece here? Well, what we can do is basically to move to a, when we find that this is not visited, so not in visit time, what we want to do is we want to add it to the queue, right? So it's going to be in Python pushing to the queue, pushing the ni and j, right? But what should be the time here? Well, if we didn't have this constraint, then the time would be just t plus 1, the time here plus 1, the time of the whatever we pop from the queue. So this would be heap queue heap pop, and this is, we do this while we have values in pq, right? Now here, if we didn't have this constraint, then it's going to be just time plus 1. But since we have that constraint, then we need to make sure we need to not start until move time. We need to not move until move time. So the next time here, or the time for this ni and j, is going to be just the max between time and the value in move time, so that we guarantee that we don't move until this time is reached, right? And then we can add plus 1s because we start moving when we reach that time. So, and for the one move to get to the room, it's just plus 1. Okay, so that's why we do that here. And that's pretty much the core idea is the next time it needs to be the max to accommodate this condition. Okay, so let's just put that here. So like this, something like this. We don't need this. We need to define our priority queue. So initially it's just zeros, right? And then we need visit time. Initially it just has the first position, which is 0, 0, which initially the visit time is just 0. So that's why we represent like this. And then here we visit the neighbors, like this. And we want to make sure that these are also within bounds. So to do that, we just say 0 and I rows and j columns, right? And then we say we need to update it in the visit time, right? So we say ni and j is equal to this next time. Okay. And then at the end here, when we reach n and m, which are going to be length of the number of rows and then the number of columns. So you can just check this like this. If we are on the last position, then we want to return the time it took to get there, right? Now in the end, we hopefully won't get to this, but we'll return -1 just in case. Okay, so this needs to have another one, and this should be m, this should be n. Looks like there is another problem here. Oh, this needs to be next time, sorry. Okay, so actually this needs to be Ni and J because that's the cell we are moving to. And this gets accepted. Yeah. So pretty straightforward. The only thing that may make you doubt a little bit is maybe why aren't we doing if next time is smaller than the existing visit time, right? If there was one, right? If there was one, instead of doing this not in visit time. And the answer there is that this will always be the case because we move just one step at a time to each adjacent cell, right? So it can be, we don't have negative edges, right? Values. So it can be that we arrive at one place first, but later we'll come back with a smaller distance. That's not possible. So that's why in this case. But yeah, that's pretty much it for this problem. Thanks for watching and see you on the next one. Bye.